Hello guys, welcome back to VC Tech. Today we are going to be talking about extended ACL, one of the most powerful tools in networking, yet most people don't really understand how or why it works. In today's video, I will explain extended ACL from the basics, its benefits, and exactly when and where it should be used in a way that finally makes sense. If you're studying for CCNA, working as a network admin, or learning network security in general, extended access control lists are something you must understand. Today we will cover what extended ACL is, how it works, its benefits, and real-world placements step by step. So with that being said, what is an extended ACL? An extended ACL or extended access control list filter traffic using source IP address, destination IP address, protocols that include TCP, UDP, ICMP, and IP, and port numbers that includes HTTP, HTTPS, SSH, Telnet, and so on. It allows precise control over network traffic. And how extended ACL works: the router checks packets against ACL rules. The rules are processed from top to bottom, so whatever you permit, it checks that traffic before it goes to the second line of the ACL rule. First match is applied. Unmatched traffic are denied because there is always an implicit deny at the end of every ACL statement. The benefits of extended ACL includes strong traffic control, improved network security, it reduces unnecessary traffic, and it is the first line of network defense. Now we'll be talking about the placement and usage of the extended ACL rule that we created. It is recommended to place extended ACL rule close to the source. When to use extended ACL? We use it when we want to restrict network access, control application, and protect critical servers. So with that being said, guys, let's head over to the configuration phase where we get to configure an extended ACL on a router and apply them to an interface to restrict a certain device from communicating with a certain device. So for this tutorial, we have 2 routers and 2 switches and 6 host devices. As we also have the same from our previous video, we have an extended ACL number configuration, and we also have an extended ACL name configuration. So these are the rules that we are going to be following for this tutorial. We are going to create this rule on this router, as we are also going to create this rule on this router. So before we get into creating those rules, let's first of all ping the devices and see if we are able to gain connectivity. I've already configured a routing protocol on the routers, so the devices on each local area network should be able to communicate with each other, since we've not created an ACL rule to restrict the traffic. So let's ping 192.168.2.1 2.1 default gateway. So yes, we are able to gain connectivity. Let's ping 2.2. Let's also check the IP address we have here. So this is the server, it's taking 2.2, and this is taking 2.3, and the last device is taking 2.4. Let's also check for this device 1.3, 1.4, and 1.2. all right, so let's ping. So we are able to ping 2.2 from this device. Let's also ping 2.3. then we are going to head over to the other local area network and try to ping for connectivity. Let's also ping with this device. So ping 192.168.2.1 default gateway of the other local area network. So 2.2, we are able to ping 2.2. let's also ping 2.3. we are also able to ping 2.3, and lastly let's ping 2.4. we are also able to ping 2.4. Let's try from this server 192.168.2.1. We are able to ping 2.1, which is the default gateway. Let's ping 2.2. We are able to ping 2.2. Let's ping 2.3. We are able to ping 2.3, and let's ping 2.4. We are also able to ping 2.4. So all the devices on this local area network can communicate with other devices on this local area network. Now let's try to ping from this local area network and see what's going to happen. So 192.168.1.1, the default gateway. Yes, we are able to ping the default gateway. Let's ping 1.2. We are able to ping 1.2, and let's ping 1.3. We are able to ping 1.3. Let's ping 1.4. We are also able to ping 1.4 from this host device. Let's head over to the second device and try to ping. We are doing this, guys, so when we get to the phase of applying the ACL rule, you're going to see the devices that are unable to communicate with a certain device. So we are pinging 1.1 from this host device, and we are able to communicate 1.2 and 1.3 and also 1.4. So we are able to ping from 5 devices for this tutorial. Let's ping from the last device, 192.168.1.1. Yes, we are able to ping 1.1 default gateway. Let's ping 1.2. We are also able to ping 1.2. So technically, our configuration is accurate, and all the devices can communicate with other devices on this tutorial. Alright guys, so let's get into the main objective for this tutorial, which is configuring an extended ACL rule. So for this router, we are going to be configuring number ACL, as we have over here, number ACL. And when configuring an extended ACL, the number starts from 100, unlike the standard ACL that starts from 1 to 99. For an extended ACL, it starts from 100 to 199. So we are going to say access list. We want to specify that number to be 100. Then we want to permit or deny a particular statement. We are going to be following this rule, guys, this rule that we created here. So we want to permit 192.168.1.2 to communicate with another host of 192.168.2.2. So how do we write that in an ACL rule? So we say access list 100 to specify that it's an extended ACL rule. Permit ICMP. Now this is the protocol that we talked about. Permit ICMP traffic to be able to reach this host device 192. I'm also going to show you that. So we have all these protocols here. However, we just want to permit ICMP packets. So permit ICMP packets to host 192.168.1.2. So we want to say permit host device of 192.168.1.2 to also communicate with another host device from the second local area network of 192.168.2.2, as we have over here. By doing this, guys, this rule right here means that we've permitted the host device of 192.168.1.2 to communicate with 192.168.2.2. The communication that they're going to be getting is a ping communication, meaning 192.168.1.2 will be able to ping 192.168.2.2. Now let's also create the second rule for this extended ACL, which is going to be access list 100. So permit. Now for this rule, we are permitting one host device, so we can say IP host of 192.168.1.3 to be able to communicate with an entire subnet of 2.0 network. So how do we do that? We say 192.168.2.0 with a wildcard bit of 0.0.0.255 By doing this, we've told the host device of 192.168.1.3 that it can be able to communicate with all the devices on this local area network. Now let's add the last line of our access control list for the number ACL router, which is going to be access list 100. We want to deny every traffic that will be coming into the network. So we say access list 100 deny IP any. This line here means that any other traffic that is not these two rules that we created, any other traffic that is coming in that is not these rules, that those traffic should be denied. Now we can see the rules that we just created by saying do show run. By saying do show run, this is our ACL rule that we created, saying that we want to permit 192.168.1.2 host device to communicate with another host device from the second local area network of 192.168.2.2. We also have a second ACL rule that says that it should permit 192.168.1.3 to communicate with the entire subnet of 192.168.2.0. And we have the last rule that says it should deny any other traffic that is not the previous two rules that we created. Remember, an extended ACL rule or an ACL rule reads the rule from top to bottom. So let's configure our name extended ACL for the second router, and it also has the rules that we are going to be following over here. Now let's get that into the system and apply this to the interface. Remember, we apply it closest to the source. So how do we configure name ACL rule? It's very similar. We say IP access list, and we want to specify that this is an extended ACL. We also want to give the extended ACL rule that we are creating the name. So we want to give this name permit. So by doing this, we are in the interface of an extended ACL. We have default, deny, exit, no, permit, and remark. Now first, let's start with the permit statement. We want to permit the host device of, so we specify the host of 192.168.2.2. Sorry guys, I did not specify the protocol. So we want to permit ICMP for the host of 192.168.2.2 to be able to communicate with the entire subnet of the local area network of 192.168.1.0. So we say 192.168.1.0, and we specify the wildcard bits of 0.0.255, and that is it. Let's also create another statement to permit ICMP packet for the host of 192.168.2.3 to be able to communicate with the another host device from the first local area network of 1.0. So we are going to say 192.168.1.3 complete host. Oh, I'm sorry guys, so we always need to specify host when we are configuring. So this host device is trying to communicate with this host device, and if a host device is communicating with another host device, we have to specify that it is communicating with another host device. It's only when it is communicating with an entire subnet, then we just have to write the IP address just as we did here. And after writing the IP address, we also need to specify the wildcard bits. Now we've created our second ACL rule for the name extended ACL. Let's also create the last rule. So we say deny IP, or let's say let's maintain ICMP, then deny ICMP any, and and let's leave this interface and see the rule that we just created. Do show run. So first we have our extended ACL with the name of permit, and we permitted ICMP host 192.168.2.2 to be able to communicate with the entire subnet of 192.168.1.0. We also created a second ACL rule to permit another host of 2.3 to be able to communicate with the host of 192.168.1.3. And lastly, we deny every communication that is not these two rules that we created up here. Now, after creating these rules, we have to apply them to an interface to make sure that the traffic, when coming into the local area network, is going to be scrutinized by the ACL rules that we just created. And where is the best placement for an ACL rule? The best placement for an ACL rule is always closest to the source. Now, closest to the source is on this interface over here, the default gateway of the local area network. That is closest to the source. That is the interface where we'll be applying our ACL rule. Now, let's start with the number ACL. So what we are going to do is we are going to say interface gig 0/0. We want to say IP access group, and we also want to specify the number. Since this is an extended ACL rule for number, we want to specify the number, and we want to say in. Any traffic going in should be scrutinized by the ACL rule that we just created. Let's also do the same for the second local area network. We also want to say interface gig 0. So what interface is that? Gig 0/1. Gig 0/1. We want to say IP access group. Then here we want to specify the name of the ACL rule that we created, which is called permits, as we have over here. We gave it the name of permits. So permits, and we want to say in. By doing this, guys, we've placed our ACL rule on the interface closest to the source. Now it's time for us to test what we just did. And bear in mind, guys, that right here we specify on the ACL rule that we want 192.168.1.2 to be able to communicate with 2.2 network. So let's look for 1.2 host device. So 1.2 host device is this server over here. And previously we were able to ping all the devices from the second local area network. First of all, let's ping 2.2 from the other local area network. And yes, we are able to ping 2.2. Wow, that's nice. Now let's try to ping something else that is not 2.2. Let's try to ping 2.3. As you can see, guys, we are not able to ping 2.3 because we've created an ACL rule telling it to only permit 2.2 ICMP traffic, while the rest of the devices should be denied. Remember, there is always an implicit deny at the end of every ACL statement. So we are not able to ping 2.3. Let's also try to ping 2.4. We are also not able to ping 2.4. While previously we were able to ping 2.4, as we have here, we were able to ping 2.4. We were also able to ping 2.3. But since we created our ACL, our extended ACL, and we applied it to an interface, we are now able to ping only the device that we explicitly gave permission to allow ICMP traffic, which is 2.2. And as we have here, permits 192.168.1.2 to another host of 192.168.2.2. So as you can see, we are not able to ping 2.3 and also 2.4 from this local area network, the server to be precise. Now let's also try to ping let's use 192.168.1.3 to ping the entire subnet of 192.168.2.0. So which device has the IP address of 1.3? So this device has the IP address of 1.3. Let's start with 2.2. We are able to ping 2.2. Let's go with 2.3, and we are also able to ping 2.3, and lastly let's ping 2.4. And as you can see, we are not able to ping 2.4. That I will show you when we get to the second local area network. So for this local area network, our configuration is accurate, as our first rule is for 192.168.1.2 to be able to ping another host from the second local area network of 192.168.2.2, and also for the second rule that we created, 1.3, to be able to ping all the host device in the subnet of 192.168.2.0. However, it is not able to ping 2.4, but we'll get to that. Now let's try the ACL rule that we created on the name ACL and see what is going to happen. So for this second local area network, the ACL rule we created says that we should permit 192.168.2.2 to communicate with the entire subnet of 1.0. So this server over here has the IP address of 2.2, and as you can see, previously we were able to ping 1.1 and also 1.2. Let's try to ping 1.2 and see we are able to ping 1.2. Let's also try to ping 1.3. We are also able to ping 1.3. Now bear one thing in mind: if we try to ping 1.4, it's not going to be reachable, because in the ACL rule that we created, from this ACL rule that we created, there was nowhere where we specified that we want 1.4 to be accessible. We only said that we want 1.2 to be able to ping 2.2 and 1.3 to be able to ping the entire subnet of 2.0, and any other IP or any other device in the local area network should be denied. The traffic should be denied. So that is why 1.4 on this local area network cannot get to this local area network, because we've already denied that statement. We did not mention it though, but there is an explicit deny at the end of every statement saying that whatever traffic that was not permitted should be denied. So that is why we are not able to ping 1.4 from this local area network, and also we were not able to ping 2.4 from this local area network, because on this ACL rule we created, we permitted the host 2.2 to communicate with the entire subnet of 1.0, and we also permitted a particular host from 192.168.2.3 to communicate with a host device of 192.168.1.3. Now let's try that. Which device has 2.3? So this device has 2.3, and on the ACL rule we created, we said that this device should only be able to communicate with 1.3 host device from the other local area network. Now let's try to ping 1.3 and see what's going to happen. Yes, we are able to communicate with 1.3. Let's try to ping 1.2 and see what's going to happen. We are going to get destination host unreachable, because the ACL rule we created, there was no place where we permitted 2.3 to be able to communicate with 1.2. Let's also try to ping 1.4 and see what's going to happen. We are also getting destination host unreachable. However, if we try to ping the device or the host that we told the ACL rule to permit, we are going to gain communication, because we've already created an ACL rule permitting that IP address. Now let's try to use the last device, which is 1.4. I believe this device has the IP address of 2.4. So previously, right, we were able to ping all the device from the local area network of 192.168.1.0. Now let's try that one more time and see if we are able to ping any device from the first local area network, the local area network that has the IP address of 192.168.1.0. And as you can see, we are not able to ping the host device of 1.2, which is the server from that local area network. Let's also try to ping 1.3. We are also not able to ping 1.3. Now let's try to ping 1.4. And as you can see, this device is not able to ping any device from this local area network, as well as this device has 1.3, this one has 1.4, as well as this device is not able or will not be able to ping any device from the other local area network. As you can see, destination host is unreachable. If we try to ping 2.3, we are also going to get destination host unreachable. Let's also try 2.2. Destination host is also unreachable. So guys, an extended ACL allows network administrator to control traffic in a precise and a secure way. Unlike standard ACL, extended ACL can filter traffic based on source IP, destination IP, protocol, and port numbers, giving full visibility into network communication. If this video helped you understand how extended ACL is beneficial to network administrator and also the first line of defense, why not smash the like button, subscribe to this channel, so whenever there is a networking video on how to protect your device and also how to set up a network, you're going to be the first to know. As on the next video, we'll be talking about NAT, network address translation. Thank you guys for watching this video and see you in the next.